the octal number system uses the 8 symbols from 1 to the 7. Octal numbers are also referred to as base 8 numbers. So guys, I said that for example, if we will take one digit, one symbol of hexadecimal numbers, it will represent 4-bit information. But in this case, what do you think? One symbol, one digit of the octal numbers, how much bit?
8
will contain? Huh?
8.
No, it contains 3-bit information. That's it. Because 8 numbers, it will be 1, 0, 0. It's already 4-bit. But up to the 7, from 0 to the 7, it's only 3-digit we use. So it's just 3-bit information. For example, here decimal, binary, and octal. Here you can see. So 7, it's 1, 1, 1. Next number 8 in the decimal, in the octal, will contain, you can see it will be 001, 000. So it's not 3-bit. So it is usefulness when you can easily convert, from the binary to the octal, or from the vice versa, from the octal to binary. So also check this table in the course book. So of course you do not need to memorize all of this value, but you should understand the difference between binary, hexadecimal, octal, how to convert to decimal, or for example, how to convert from the binary to octal or to the hexadecimal. So that's it. This kind of difference you should understand. For example, here's some converting an octal number to binary. So for example, you have 6, 7. How you should pronounce? You should say not 67. You should say 6, 7 base 8. Okay. So your goal is to convert to the binary. So you just write down separately 7 and 6. So 7 from the table you can check it will be 1, 1. 6 from the table you can see it will be just 1, 1, 0. Then you just combine these two binary numbers and you will get that 67 base 8. In binary system it will be 1, 1, 0, 1, 1, 1. So it's the same as with the hexadecimal. It's very easy conversation. For these reasons, programmer and people who work with electronics, they use hexadecimal and octal systems because of easy to conversation from one to other. And converting a binary number to octal. For example, you have this binary number. It's too long to pronounce, but the idea you need to separate to the 3-bit. For example, 110, 001, 100. So you will consider each 3-bit separately, and 3 first bit you just find in the table. It will be 5 in the octal. Next will be 1, and last one will be 4. You just combine them. You will get 4, 8, 5 base 8. So a little bit weird to pronounce, but we could not pronounce it 415 because it will be in the decimal. Here it just will be 415 base 8. Okay, so I think for now we considered, and not yet. So other steps, for example, converting an octal number to decimal. So the procedure is the same. For example, if you have 415 base 8 number, and you need to convert. So it's the same procedure. First, you write down the octal number 415, then above but it is not necessary to write. You can just, do it in your mind, but you need to understand place value. So first position 5, its value is just 1. So second digit from the point, its value is 8. Next one 64. So it's different from hexadecimal, it's different from the binary. So next, what we will do, for example, here is the value 1, the number is 5, just 1 times 5 will be 5. Next number is 1, its value 8, just 8 times 1 will be 8. Last digit, our 4, its value is 64, you just multiply. 64 times 4, it will be 256. You just sum up all of this value, you will get 269 in decimal. So the approach, no, the method is the same, but difference it's place value. So please, actually you do not need to memorize place value. So you just need to understand that if we will work with decimal, here it will be 2 power of 0. Next 2 power of 1, 2 power of 2, and go on. But in the case of hexadecimal, you need to use 16 power of 0, 16 power of 1. In the case of octal, you need to use 8. Okay. So next, converting a decimal number to octal using the repeated divided by 8 process. So process is the same. So for example, we need to convert 498 to the octal number. So it's a decimal number. So you just divide by 8, write down remainder, then again divide your quotient, write down remainder, again divide your quotient, write down the remainder, and you see that 498 in decimal, it is equal to 762 base 8 number. So for this, we actually recalled all the numbers that people use in computer science, in electronics, and you should know. Of course, we know what is a decimal number because we use it in our everyday life, but also you need to understand what is a binary, how to convert from the binary to decimal and vice versa. Next, we recalled what is a hexadecimal number, how to convert not only to the decimal, but also to the binary and vice versa. And also recalled octal, but octal now is rarely used. So mostly it's binary and hexadecimal numbers. So next one, I think you know this terminology, what is a bits, what is a bytes, but also I've never heard before nibbles, and also there is word size. So it's just what is, it's just, you know, units of data, right? So for example, a single number is either 1 or 0 on 1, it's called a bit. So you know it. Bit is an abbreviation for a binary digit. The bit is the smallest units of data in digital system. So physically, what actually we're doing in digital system, we assemble, construct some devices, digital circuits that, you know, we give input some high or low value, and on the output we get high or low value. So actually in the digital circuit we operate with this number 1 or 0. So it's 1 bit of data. For example, you can see this magnetic storage medium, hard disk, we say. So actually, you know that there is some small sections that can be either 1 or 0. Or, for example, an optical disk. If you will look carefully, you can see some small pit. If you have pit, we say 1. If we don't have this pit, we say 0. So that's it. So, but let's recall what is so 1 bit is just as 1 or 0. Nibble. So it's just 4 bits, such as, for example, 101. You should know what is a nibble. It's just 4 bits. Byte. It's 8 bits, such as You can see 1110, 1111. And also, I don't know how often is used this terminology, but also 16 bits, it's called word, because some usual word usually contains 16 bits. I think for this reason, people call this size of information, they call word. Okay, there is a double word, it's 32 bits. There is quad word, it's 64 bits. Okay, if there is other kind of, you can say me. And other things that you should recall, that you should know, is that mostly we use not bit, mostly we use bytes. But bytes, 1 byte is a small number, small date of information. So we use kilobytes. So you should understand that kilobytes is 2. We exponentiate it to the 10. Or just this 124 bytes, megabytes, gigabytes, etc. Okay, I think you know it, but it is not necessary to memorize. You can just search, find in Google what is kilobytes, megabytes. You can find some software that can convert, but you should understand what is a bit. It's information that contain 2 values, 1 or 0. What is a byte? I think bit, byte, it's things that we use a lot. Okay, I think for now we can do some summary, and then we'll come back. We'll have time to the multi-slim, and I will want to show you some things that you will need tomorrow when we will do your lab. Okay, let's go through the summary. So first, the decimal number system contains 10 symbols, so you know it. The binary number system contains 2 symbols, 0 and 1. The place values left on the binary point in binary are, so just you can calculate, but you should know it. At least for up to this number you should know, if you're not able to calculate. Next, all people who work in the IT field must be able to convert binary to decimal numbers and decimal to binary numbers. So of course, you can use calculator, but it's better if you can do it, without calculator, just by hand on the paper. Next, we define what is encode, decode, what is encoders. So encoders are electronic circuits that convert decimal numbers to binary numbers. So, and in LabWorks, we will work with encoders. Decoders are electronic circuits that convert binary numbers to decimal numbers. So also tomorrow we'll work with decoders. Next one, by general definition, to encode means to convert to readable code. So sometimes you do not need to give, some exact definition, just understanding. So encode means to convert the readable code that's more understandable for us, to some encrypted code, such as binary. So by general definition, to decode means to convert a machine code such as binary to more readable form, such as alphanumeric. Next, we today recalled repeated what is a hexadecimal number system. So you should know that it contains 16 symbols. So from 0 to 9, but then we need to come up with new symbols, A, B, C, D, E, F, we just use from the alphabet. And what also important, you should understand each of this digit from 0 to F, actually it is 4-bit data. Next, hexadecimal digits are widely used to represent binary numbers in the computer field. Okay, the octal number system uses 8 symbols, so from 0 to 7. So here you should understand that any of this digit, it's 3-bit data. Octal numbers are used to represent binary numbers in few computer systems, so it's not so widespread, but nevertheless, you should know it. Data grouping have common names including bit, nibble, byte, word, double word, and quad word. So guys, I have a question. I'm not a computer scientist, and of course I do some programming, for example, in Python, when I do some modeling in my field. I use Multislim software and other to design circuit, but I know what bit, byte, but how often you use such terminology as a nibble, word, double word, and quad word in computer science? Do you use this? Yes? Do you use this nibble, word, double word, and quad word terminology very often?
No.
No. So you talk about bytes and bit, right?
Yes.
Okay. So, but you should know that there is other common names. So nibble 4 bits, word 16 bits, and okay. So how much time we have? Oh, we have about 20. Okay, so it's good because I want to show you some assembling. Okay, so tomorrow on the lab. Okay, before I will go to the lab and explain something about lab, do you have questions for today's lecture? If you have some question, you can ask. Okay, let's go in this case. So guys, please let me come back to the homework. Please do not, postpone your reading, because I was also students, and sometimes I also was lazy and postpone reading some book, but at the end it will very hard to catch up. So please try to read every week. So this week, please, on the weekend, read lecture 2, chapter 2. Okay, I already uploaded the book, so you can go with your pace. You can read. If you have time, you can read third chapter, fourth, but you should understand that every week you need to at least read one chapter, because you will do labs work and you will do test. So labs and test, it's the main source when you will get grading. Of course, then I will check homework and other assignments on. Sometimes I also grade based on the homework, but it will be additional. So main it's a test and labs. Okay, review labs 2 for tomorrow work. I also uploaded to the Moodle. Okay, so let's talk about tomorrow's lab. So your task tomorrow, it will be to assemble this circuit. So what kind of circuit? So the purpose of the circuit is to show you how to utilize, how we can convert decimal number to binary number. For it, we need encoder. So we will use integrated circuit 74147 as an encoder, but you should understand that output of this encoder, it's not a real binary number. It is inverted. For this reason, we need inverter. So here you can see inverter. So what's the task of the inverter? If you, for example, if you here on the 9 pin, you will get 0, inverter just will, give us complementary opposite state. It will give us 1. If we here we have 1, it gives us here 0. That's
The
it.
triangle is inverter, yes?
Yes, 7414, it's our inverter. Okay, so in order to, if you will use, for example, some 7-segment layers, our circuit become very complicated. Of course, we will use, but later. For now, we need to go from the more readable circuit, from easy circuit to more complex. So for this reason, your output will be just LID. So it is real circuits that can be, actually assembled by hardware when we have real integrated circuits, this keyboard, etc. But they also offer more simple version. So actually it's 2-1 lab experiment using encoder, but also there is multi-slim version 4-2. So actually it doesn't matter, you can assemble this one, but you can also assemble this one. But I should notify that in the multi-slim we don't have this simple keypad. I don't know why they have not included it, but in the multi-slim we don't have this keypad. We have some keypad. For example, let me show you. I will create new one. Place component, guys. In here you can see advanced. Here you can see should be here. I don't know. We have this kind of. So for example, if I'll take this one, so it's very, actually you could not directly wire it to this our encoder, because for it we need some additional circuit. So if somebody wants, I don't, you can do it, but it will be very difficult to do on lab. So we can do, yourself at home. You can try to connect this one, and it will be more complicated, because for it you need to use other integrated circuit, that will able to utilize this one. So for these reasons, what we'll do, we just use this key, this switch, and just will name it. For example, key 1 is our 1 number, key 2 number, etc. So, okay. So instead of this one, you can assemble this one. It's the same, but more simpler, this one. For example, here when I, for example, press 8. So you should understand that this light first will be light. This here will be 0, 0, 0. So it's 1, 0, 0. 8, it's 1, 0, 0. Okay. Next, lab experiment using a decoder. So it's in the previous one we will convert decimal to the binary. By this circuit, you will convert binary to decimal. I already showed my simulation. So also here you will use key, and you will use decoder, and for the decoder use 7442 integrated circuit. Also here you should use inverter. Why? Because it does not give us a real output. It's give us this complementary output. For this reason we need to use inverters. So it's not hard work, actually. We can do it. And after, so next task is to assemble this counter. So for example, when we apply to this pin 1, when we apply some digital signal, for example some pulse, it will count. If we have series of pulse, it will count how much pulses we have. So actually, for this reason, we need to use this counter. You will use integrated circuit 74HC393. So, but I want to show you. Okay, let's remove this one. So actually, we don't have exactly the same ones. So here, all groups, 74HC393. S, then what was 393, like this. Okay, so we have 4 options, so you can use, doesn't matter, they're just, you know, voltage is different, but use 4 volts, okay? So, but pay attention. Okay, let me increase this one. Can you see the difference between this one and let me put it here. Don't know. Okay, copy. Can you see the difference between from the multi-slim integrated circuit and on the scheme?
Yes.
Yes.
So what do we need to do? So we need to think about it. So actually we need to use 2 ones, okay? So actually you need to place like this, then sync and then connect. Can you see? So actually this pin 1, well, for example, this pin clear 2 and 2 you need to connect wire together, okay? So please, I will not explain all of this thing, but we don't have single one, we have 2 ones, but you need to properly wire it. It's not so complicated, just look carefully, think a little bit, and I think you can you know, understand. Next one that I will show you, okay.
Teacher, sorry, I have a question.
Yes.
Why the 13th pin in the picture is connected to the 6?
Very nice question. I will ask you about it tomorrow, but I will give you some clue. For example, when we'll start, first we'll work these lower ones, but you know it had some limits, so it will when it reach 1 1 1 1, so it can't further because it's his limit. So then this integrated circuit will send signal to the second one and will start this one, okay? For this reason, when it achieve 1 1 1, this pin gives signal to the KLK, to 13 ones, and it will start counting this one. So actually this one count faster, this count more slower. Why? Because this, we should understand that place value for this is our first impulse, and etc. So just look, it's very difficult, you know, now to explain, but tomorrow I will show on the labs.
And another question, how
Yes.
we will connect VCC power supply and ground to the 2?
Yes, great question. It means if we don't have, it means that it's already connected.
So it contains 5-volt power supply, or we'll change it in the...
This means that this one's already connected to 4 volt and also connected to the ground. Okay, it's a very nice question. When it is not shown, it means it's already connected, wired to the ground and to the VCC. Okay, and so let me also show you what kind of key you will use. So let's come back to this. I will copy. If I need to open Paint, copy to Paint, then from the Paint, Oh, it's better. Yeah. So guys, okay, so you need to find switch. So in the multi-slim we have a variety of switch, but I will show you what kind of switch to use. So first, you need to go to the, I think, basic, and from the basic you need to choose switch, and here you need to this one, okay, SPDT. Please SPDT, okay. So then here you can actually click on the right button and flip horizontally, for example. Not like this, okay. Flip vertically, not like this, maybe vertically. So just you need to try. So I need to
rotate.
So rotate. Okay, so like this. So first, okay, you'll take VCC. For this, you need to go to the all groups. I will show only one connection, okay? So I don't know how to move this one. Maybe I need to delete, okay. Also delete. So guys, next I will choose my integrated circuit. So what kind of, do you remember? 74147, right? This one. So here I also, guys, be careful, because you need to connect not to the where the pin is. So you can see here pin numbers, but also output, input. So you need to connect, for example, if their switch will be your number 1, then in this case you need to connect to 11 pins, because 11 pins will convert 1 to the binary 1, okay? Then this part you need to connect to the to wire to the ground. This part. So guys, see, now I am applying to the pin 11, I'm applying 5 volts. So in order to activate, to give signal, I need to apply the, you already, how can we, it was question, how can we apply low value? So just switch, can you see? And now you apply low. Actually, this bubble here, bubble means that you should, to activate this pin, you need to apply low. Bubble means, okay. So it means that here we assume that we give to the integrated circuit number, decimal number 1. It should give us here on the output, it should give us number hour, but in the binary, and it will be, so this one will be 0, 0, 0, and this should be 1. But here you can see also bubble. Bubble means that it is inverted. For this reason, we need to invert. It's not a real one. So actually, it will give us here 1, here 0, 0. So we need to actually connect here converter. So inverter. So for inverter 7404N, you need to add 740, this one. Okay. 4, yes. So actually, next lesson we will study the logic elements and what this triangle actually means. So actually, I will connect here. So it means, for example, if here we will have 1, output will have 0. If you have 0, output will be 1. So next you will connect to the LID resistor to limit current, and that's it. It will be your work. But you need to connect other switches. Okay? Do you have questions about multi-slim, how to do other things? You can ask. Guys?
I think no question.
Okay, so let me check this one. I think here it's more, all things is understandable. And so this one, okay, I will show you how to find clock, because here you need to, actually you can use the clock that actually you assembled labs 1, but here also we have clock, so better use clock because it will take small area on this on the board. So for example, how to place component, and just type here clock. Because we need to use voltage clock. No, it's not this one. So actually I use here, let's see I use this device, digital clock, okay. This one, digital clock. So that's it. Here you can just change value for just frequency. 1 kilohertz is very high frequency. Just change, decrease to 50. That's it. So I think now, tomorrow you should able to assemble this 3 type of circuits. So first one, this one will allow convert binary decimal to binary. Second, this one, it will be do opposite, binary to the decimal, and this one just will count, just will count impulses. Okay guys, I think for now our lecture is over. If you have some times or some questions about lecture, about assignments, homework, labs, you can ask.